Hey students! How you doing? Mr. Helpern here. This is your first video number 1. And we are going to be talking about chemistry, particularly conserving matter in this unit. Now, conserving matter is extremely important. So important. Well, why? Let me think about that. Well, one thing that we need to know is that it's actually a law. We've actually created a law called the Law of Conservation of Matter, right? This law is a law because we have a lot of observations to prove that it exists, that this actually is something we should be remembering. And so we call it the Law of Conservation. So on your notes, what you're going to write in the first page is, as I start typing, you're going to start writing down on your page, your guided notes page, which is on the portal. So go to the portal for that. All right. So I'm just going to click here. All right. You can see my little text box open up. Right. And we're going to talk a little bit about the law of conservation of matter. All right. So the law of conservation of matter states that matter can neither be created or destroyed. All right. So that's a fundamental part of chemistry, and this is really important when we're talking about balancing equations. Okay. What this means is that when we're talking about an equation, a reaction, particularly chemically changing something from one molecule to a completely different molecule, we're talking about the fact that the number of atoms of each element is the same on the reactant side as it is on the product side. Okay? Take, for example, this picture here. We have the reaction of one carbon okay, and that carbon atom is reacting with oxygen gas. All right, so this is one oxygen molecule. Notice I didn't say oxygen atom, right? Because this is not just one oxygen atom. It's an oxygen molecule. It's a diatomic molecule. All right. So we have that, and as a result, we have carbon dioxide. One carbon dioxide molecule. Okay. Now the importance of this as it connects to the law of conservation of matter is that if you look on the left-hand side, the reactant side, and this is the reactants over here, all right, if you look on that side versus the product side, you'll notice that the number of atoms of each element is conserved. We have one atom on the reactant side, one atom on the product side. We have 2 atoms of oxygen on the reactant side and 2 atoms of oxygen on the product side. So that's huge. Okay. So when we talk about describing matter, right, we can describe it in many ways. One of the ways is by showing it in a model, as you see there in your notes, but also another way is using coefficients. So coefficients are used in chemical equations, right? So coefficients, all right, they indicate relative number of units of each substance in a chemical equation. make that a little bit smaller. All right. Now, for subscripts, those are a little bit more specific. Okay. Subscripts indicate the number of atoms for a particular element. Okay. For example, we have 2CO2 or 2CO2. All right. We have that. All right. The 2 in this case is the coefficient. Okay. So that's the coefficient there. All right. So this is the coefficient. All right. Now let's see if I can do this way. Coefficient here. All right. The superscript, or subscript rather, is this number here. That's the subscript. All right. So big S. All right. And we have coefficient here. All right. So as we move this around a little bit, so this is just an example of what you're going to see in chemical reactions specifically. Okay, so that's an example. Okay, all right, going down to the bottom. One thing that you do want to note, oh, by the way, the whole reason why we talk about the law of conservation of matter is it might be kind of complicated. If you think about gas coming out of your car, it's a little bit challenging to think about it that way because, you know, if you put it into the car, right, and then your car goes and you lose gas, right, it was in liquid form, well, what happened to that gas? Did it disappear? All right. Hopefully by now you should be realizing, because we've been doing a lot of chemistry, is that it's not disappearing, right? It's not being destroyed, right? It's not also just being created when we put it into our gas tank, okay? It's being, you know, changed to a different form, right? Carbon dioxide, right? From, you know, gas, from propane, or from, you know, other sources of gas. So, you know, we have to understand that it goes back to the law of conservation of matter. The last thing I want to say in this video is that if you look down at the bottom there in the picture, we have different ways to look at matter, all right, when we talk about matter. We have the particulate level where we can look at models of it. We have, you know, solid, liquid, gas, and that's a great way of looking at it. And we use models to represent the change of numbers of atoms, right? The change of shapes of different molecules. We also look at the macroscopic, right? So metal ores, right? The combination of things, something that you can put in your hand. It's not a drawing of it. It's the actual physical representation of it. And then we also have the symbolic level where we're doing chemical equations. We're writing out equations with coefficients and subscripts. So right here you should note that there are 3 ways to describe matter. Okay, first one, talk about the particulate, all right, level. Oops. Second one, we have the macroscopic level. And then the third, we have the symbolic level. So in this particular unit, we're going to be talking about all of these, okay? And that ends the first video.